Hi, this is day 10 of the 30-day HackerRank challenge. Really, this is the 11th challenge. So we'll go through it today. We'll be working with binary numbers. I'd recommend watching the tutorial video. They have it every 10 days. It's pretty good. I enjoyed it. So in this problem, we're looking at converting a base 10 integer to a base 2 or binary number. And from there, we got to count the number of consecutive ones within that new binary string or array, however you're storing it. The implementation of it behind the scenes is not as important as the algorithm that calculates consecutive ones, because it's going to be the same either way, whether you're working with strings or you're working with array slots. So let's go through the first one. This is going to be the easier one. I took a shortcut for the first one, and then I'll show you how to implement it with pure Python. Right now I'm using a standard library after I've taken the input, and after it's stripped, it's converted to an int or an integer, and so the int function wraps around the raw string that is now stripped. So when you're given 13, there's no more white spaces. Essentially, I'm using a Python standard library function, binary, which converts the integer to a binary string. When it converts to a binary string, it has a 0b in front of it. And so what I'm doing is taking the third index. Remember, it starts at 0, so the third index onward. And that gives you your binary string. And then we go through a simple formula that I'll talk about in a later solution. But I just want to tell you that you could easily convert in Python integers to binaries, and it's very useful. So let's go to the real example on what I want to show you and how to do it all native in Python. C++, we actually split out this function down here, and we'll talk about that later. So once again, this is generic input of different header files that are associated with Python. The shebang up here just means that it's running on Linux, probably like a Apache or Ubuntu that is hosted for HackerRank. So in our function, we're looking at consecutive ones. That's the end goal. And we're passing it a binary string or an array with ones and zeros. So we looked at the binary string in the last one, and I'll show you how to calculate it later on, how to calculate it differently later on. But essentially, you need to have two different variables, both storing zero. What I was trying to say is you can have it all on one line, where it would be something like this. Instead of splitting it out, but it makes it easier for certain viewers just to make sure you spell everything out. So after we declare the two variables, running ones and max ones, we run through a simple for loop looking at the indices associated with 0 to the length minus 1 of the size of the array. In order to do that, we use the range function within Python, and we determine the size of the array by the length function within Python. And this will give you the length plus 1. If you're looking at 0 indexing, it's going to give you the length if you're looking at 1 indexing. And so the convenient part here is range within Python goes 0 to the length minus 1 of whatever is inputted here if you're only giving it one value. And so from here we check each array slot, or if you're looking at binary strings, each char within that given section of the string. And if it's equal to 1, you add it to the running ones. However, if you find that it's equal to 0, you want to count and see if it's more than the max ones associated with the entire array. And if it is, then you store the running ones into the max ones before you zero it out. The problem here is if the last element is actually a 1, you won't be able to count the max ones. So if they're all 1s, then you would return 0 if you didn't do something else. And that something else is checking to see if max 1s is greater than the running ones. If for some reason the running ones ended on a 1, then you can return the running ones. But if it didn't and max 1s is the true value, then you can return max 1s. In order to get that array of 1s and 0s or binary strings, instead of using the Python function bin, you can actually calculate it, and we'll separate this calculation into a function later in C++. But essentially, this was covered in the tutorial, and what you do is you take the integer that you got from your input and you see if it's greater than 0. If it's greater than 0, you take the modulo of 2, and that will be your remainder. And so if you have a remainder that's anything above 0, then you add it to the array slot, or array, array. And then you can also add it to your binary string, but that would be concatenation in that case, and in this case it's appending. After we get the remainder, though, we want to make sure that we continue to divide so that we are not running into an infinite loop. And in order to do that, we need to divide by 2, since we're working with binary or base 2. In Python, you need to make sure that you include 2 divisors, like 2 slashes, divisor symbols, so that it knows to take the true integer division instead of taking the division and using it as a float. So to reiterate this, if you use 1 divisor symbol or 1 slash, then essentially you're going to get a float from that. But if you use 2, you're going to get a true integer division. So after that, you can print and see what your result is going to be, how many consecutive ones you have. So for C++, we do almost the same thing, but it's different syntax. And one other thing we do is we split the conversion to a binary string or to an array with 1s and 0s out. And in this case, in C++, it's not called an array. We're looking at a container of vector data type, and the container is going to hold an integer data type. So what this means is you have a vector that's defined within the standard C++ library that then takes an integer that's stored within a container. So think about the vector being a box and the integer is being thrown into the box, but it's going to be in an orderly fashion. So kind of like stacking dominoes. Going further, C++ is very type heavy. You have to do a lot and make a lot of code to make it run. Unlike Python, where you can use a few lines and make it work properly. So HackerRank provides a lot of generic templates so that people coming to solve problems don't have to, spend half an hour just getting ready, especially when those problems use the same R trim and left trim over and over again. So we've covered left trim and we've covered right trim. What we're adding here is a consecutive ones function and a convert to binary function. So the consecutive ones is going to take, remember that vector container that's holding integer data types, and we're going to call it an array. Also, it's going to return an integer value. The convert to binary is going to take in a number, so it's going to take in an integer data type, and it's going to return the vector container we're looking for with integer data types. So looking at the main code, it's very simple if you hand this off to somebody, but they're going to have to look at the header and the implementation files to verify, what was declared ahead of time and what was split off into the implementation file, the .cpp file. Now, HackerRank doesn't differentiate multiple files, so it's all like splat onto the page. But essentially, this would be the header file. These would be in the implementation file, and this would be in the main.cpp file, including your includes. But you would also, so this gets a little tricky. Sometimes people put the header files, so the header statements like include, vector, in your header files, but they don't include them in other files, which is the standard practice to make sure that you include header files and you don't duplicate your efforts. But some people, on the other hand, take the pound include vector header file, or like header statement, and include it in the header files and in the main.cpp file, and that's not okay, not kosher. So going further, we declare a string variable ntemp, and that ntemp is then passed to our getLine function. The first parameter is going to be standard input, or CN, and the second parameter is going to be our string variable ntemp. After we pass getLine and we get the information stored at the memory address associated with this string variable, we then want to strip it left trim and right trim to clear all white space and garbage. And then we pass it to a string to integer function defined within the standard library, so stoi, and that gives you your integer variable n. N is then passed to convert to binary, which then is passed to convert to, or like consecutive ones. We're determining the amount of consecutive ones, and we're going to put that to the standard output or the screen, and then we're just going to end that line. And so we talked about this in Python. We'll touch upon it briefly in C++. So first, we're taking that integer variable n, and we're passing it to convert to binary. It takes a remainder, or we define or declare the remainder. We define or declare your array, and then we push back all the remainders that are associated with modulo 2 on the number, with each iteration dividing by 2. And then once it is 0, then we can return our array, and that's going to return it to the consecutive ones function that we defined before. And this consecutive ones function is going to pass the vector int array into our function, and we have to declare our two integer variables, and from there we do a simple for loop over the entire array, and we determine where the running ones are and where the max ones are, and then we can return the value that's associated with it. And that's going to be the conclusion of this video. I hope you continue watching these, and I hope you have a great time learning C++ and Python. Thank you for your time. Have a great day. Bye.